Hello, my awesome scientists. So tonight we're going to talk a little bit more about forces. We started in class talking about force, how force is either a push or a pull. And now we want to talk a little bit more about the effect of force and how we can design an investigation to test the different forces that are found in this world. Okay, so this is the handout that I gave you in class today. You do need to be on page 61 in your journal. You will fill this top part out as you look at the PowerPoint, and then we will do this part together. But all the information you need for these blanks is in the PowerPoint. Okay, so the first thing we need to know is that an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by a force. Okay, just like this ball right here. Okay, if I throw this ball, it's going to stay in motion until a force acts upon it. Now, many different forces can act upon it. My hand can catch it. That would be a force pulling it into my hand. Or if I roll it on the table or on the carpet or on the grass, eventually that surface is going to create enough friction and cause it to slow down or stop. Think about when you play soccer. Most of you play soccer, and you kick that soccer ball in a grassy field. Okay, on the soccer field is made of grass, and that ball, when you kick it, it stays in motion until a force acts upon it, doesn't it? Now that force can be many different things. Sometimes it's another player's foot who puts their force on the ball, causes it to change direction. Sometimes you kick it and it goes past the goal, and it keeps on going and going, but eventually it comes to a stop because that grassy surface is creating friction that's going to cause the ball to slow down and stop. So the first thing we need to know is that an object in motion will stay in motion, an object at rest will stay at rest unless acted upon by a force. Okay, we can measure force using a tool called a spring scale. The spring scale is this little tool right here, and it measures the Earth's gravitational pull on an object. And it's actually in units called newtons. But basically, you can attach an item to the spring scale and hold it, and it will tell you how much force is being applied. It basically tells you the Earth's gravitational pull on that object. So you just need to be familiar with the fact that a spring scale is used to measure force. Okay, so then we have different things that can affect how much force is going to be applied or how much force is going to be needed to either make an object go or to make it stop. So the height of an object can affect the amount of force that is going to be there. I can bounce this ball from right here. The higher I bounce it, the higher it goes. Oops. Okay, that's because I changed the height that I held the ball. The higher I hold the ball, the higher it bounces back. And that's because what force pulls this down? Gravity. And the higher it is, the more time gravity has to work on that object. The more time that gravity has to work on that object, the more force it's going to apply once it hits the ground. Okay? So the key there is that the higher I put the object, the more time gravity has to work on that object. Another thing that can affect force would be the mass of an object. Okay, think about a full box as opposed to an empty box. Which one is going to be harder to push? The one that's full of stuff. Okay, that's because it has more mass, and more massive objects take more force to move. Less massive objects don't take as much force to move. Okay, so if you think of your desk in Mrs. Cabrera or Miss Waiter's room, and you think of the lab table in my classroom, which one's going to have a greater mass? The lab table. So if you try to push the desk and then you try to push my table, which one's going to be harder to push? The table. So the mass of the object can also affect the force needed to move it or the force needed to make it stop. Another thing that can affect force is the friction of the surface. One thing I want you to start to memorize is that if they're talking about different surfaces, then that's your clue that they're talking about friction. Okay, I can have a rough surface, a smooth surface, and depending on that type of surface is going to determine the level of friction that I have. If I have a rougher surface, such as carpet, then I have more friction and the object's going to move slower. But if I have a smooth surface like a tile floor, there's less friction. If there's less friction, then the object can move more easily past that surface, okay? Just like when we have icy roads on our street, we usually cancel school, don't we? And we cancel school because the ice has reduced the friction on the road. And what happens when when cars drive on that ice? Okay, they tend to slip and slide, and it can be very dangerous. That's because there's not a lot of friction, so it's allowing the cars to move easier, okay? But then again, on the other hand, if I have carpet or grass or sandpaper, that surface is really rough, okay? Things can't move as easily across that surface. The rougher the surface, the more friction, the less rough, or the smoother the surface, the less friction. Okay, so now let's talk about designing an experiment with force. And this is something you're going to have to be very familiar with, and you're going to have to be able to pick out what they're testing, what tools you're going to need, what variable is changing, and you're going to have to get in the habit of looking for those key words. This is going back to the beginning of the year when we talked about variables, trials, the scientific method. Okay, so we are going to be at this bottom table in your notes, and we're going to fill in this chart, and we're going to figure out how to design a force investigation. Okay, so first of all, let's look at what do I want to test. So the first thing, the question that they want to test is, how does the surface of a ramp affect the distance a toy car rolls? First thing we want to look for is a keyword that might tell us what they're testing. Okay, and first of all, it says, how does the surface, okay, so we know the keyword is surface. And remember, we just talked about if they're talking about different surfaces, then they're talking about friction, okay? They want to know how the surface is going to affect the distance a toy car rolls. That's how they're going to measure it, okay? So when we set it up, we have to look at the variable that needs to be changed. So if I want to design an investigation to test how does the surface of a ramp affect the distance a toy car rolls, I have some variables that I need to change. Actually, I have one variable I need to change, and then I have the other variables that I need to keep the same, okay? So in this case, what do you think I need to change? So if I want to test how the surface of a ramp affects the distance a toy car rolls, how do I set that up? Okay, so I'm going to have different ramps, okay? And then each ramp is going to have a different surface. Okay, so the variable I will need to change is the surface. Okay, so I can use things like carpet, sandpaper, wax paper. Okay, basically I just need different surfaces to roll the car down the ramp on. Okay, that's what I change. Remember, that's the independent variable. Okay, then on the other hand, there's variables that I will need to keep the same. If this is what I want to test, then this is the only thing that can be different. Everything else in my setup has to be the same. Okay, so in this case, I need to keep what the same. Okay, so if I'm changing the surface, I have to keep the height of the ramp the same. Okay, I can't change that. I have to have the same mass toy car. Okay, I can't use a different toy car. Okay, and that's to help keep it valid and reliable. Okay, I change what I want to test. Okay, everything else in the setup has to stay the same. The height of the ramp has to be the same. The mass of the toy car has to be the same. The only thing that I can change is the surface of the ramp. Then that will truly be able to tell me how the surface is affecting how that toy car rolls, how far it rolls. But if I start changing the height and the mass, then I don't know what's really making the toy car go a certain distance. So I have to only change the one thing I want to test. Okay. So at this point, you're going to do the other two on your own. If you would like to keep on watching, you can. If not, then you can do the other two on your own. If you want, you can do the other two on your own and then come back to the video and check it and see if you got it right. Okay? All right, so let's look at our second question. How does the height of a ramp affect the distance a toy car rolls? Very similar question, only this time they're testing something different. This time they want to know the effect of what? The height of a ramp. Okay? So they're going to change what this time? The variable that they will need to change in the setup is they're going to have to change the height of the ramp. So I might have one at 50 centimeters, I might have one at 100 centimeters, and then I might have another ramp at a height of 150 centimeters. Okay? That's how I'm going to set it up. Okay? Then everything else needs to be the same. So in this time, can I change the surface? No, because that will affect the amount of friction, and then that won't tell me how the height is truly affecting it. So things I need to keep the same would be the surface. I would also need to keep the same the mass of the car. Okay, I can't use a different toy car. It has to be the same toy car every single trial. The only thing I can change is the height of the ramp to make it a fair, reliable test. All right, let's look at our last question. How does the mass of a toy car affect the distance a toy car will travel? Okay, so this time, same question, but I'm just changing what I'm testing. This time, they don't want to know the surface. They don't want to know how the height affects it. They want to know how the mass of the toy car is going to affect the distance. So can I change the surface this time? Can I change the height this time? Absolutely not. The only thing I can change this time is the mass of the car. Okay, so I might have one that is 10 grams, 50 grams, and 100 grams. And then I will test it after I will roll each one down the ramp and see if the mass is going to affect how far it will go. Remember, the distance, that's just how I'm measuring the effect. Okay, that's not what I'm testing. What I'm testing is what I change in my setup. The distance is how I measure how the mass is affecting it. Okay, and then of course, the only thing I can change is the mass of the car. I then have variables that I will need to keep the same. Okay, so this time, can I change the height of the ramp? Nope. So the height of the ramp has to stay the same. Can I change the surface? Nope. So the surface will need to stay the same. Okay, so when you have questions like this, you're really going to have to pay attention to what they're testing, and basically whatever they're testing, whatever they want to know the effect of, then that's what you're going to change in your setup. And that's what you need to be paying close attention to, and we'll do a lot more work with this week. So make sure you have everything filled out, ready to go in your journal, and be ready to discuss it and design your own investigation tomorrow. And I will see you then.